So we've got a percent composition problem here. We've been given 2.21 grams of strontium, 1.79 grams of chlorine. And what we need to do here in order to get the percent of strontium, for example, would be to say percent of strontium is going to equal mass of strontium over the mass of strontium plus the mass of Cl. As this is the way that all percent composition problems are. It's the mass of what you want divided by the total mass, and in this case it would be 2.21 grams over 2.21 grams plus 1.79 grams multiplied by 100%. That'll give us the percentage of strontium in the compound. To get the percent of chlorine, what we can do is take the 1.79 divided by the total, also realizing that these two percentages are going to have to add up to 100% as well. The next thing we need to do is find the empirical formula of the compound, and in order to do that we're going to need moles of each element. So starting out with strontium, moles of strontium would be the 2.21 grams of strontium multiplied by, we'll have grams of strontium on the bottom, we'll put moles on top. The relationship here, 1 mole is equal to 87.62 grams of strontium. That's the atomic weight of strontium right there. That's going to come out to be 0.0252 moles. Moles of strontium. We'll do the same thing on the chlorine. Moles of chlorine is going to be 1.79 grams of Cl times, we'll have grams of Cl on the bottom, we'll have moles of Cl on top. 1 mole of Cl, 35.45 grams, and that's going to be 0.0505 moles of Cl. In order to figure out the mole ratio here, we'll take the smallest number of moles and divide it into each of these. That'll be 0.0252 and divided into 0.0252, and that's going to equal 1, and that will be for the strontium. And then we'll do the same thing for the chlorine, 0.0505 moles divided by 0.0252, and that's going to be 2.00, and that will be for the chlorine. So you can see that these are going to be whole numbers basically, so the multiplier here will be 1 for each. We don't use another multiplier because these are whole numbers, so we end up getting our empirical formula of SrCl2. Had this come out to be something like 1 is to 2.33 or 1 is to 2.5, then you'd use a multiplier other than 1, but since these are whole numbers, we'll just go for 1 and 1 here, and our empirical formula will end up being SrCl2 with the ratio of Sr to Cl being 1 is to 2, and that's how we come out of our empirical formula.